Hello. So the second and really only other technique we have for solving oblique triangles is called the law of cosines. And when would we need such a thing? The simplest way to put it is we need it anytime we can't use the law of sines. So we're going to start right off with an example. I am giving you a triangle and I'm asking you to solve it. And we have two sides, and they're what we call the included angle, which means we don't have any way of getting this other side because it's not a right triangle, which means we can't have this angle and its corresponding side. And then we don't have any way of getting either of these two angles because we need more than one angle to get the third one. So here's what the law of cosine says. It's like a more complex version of the Pythagorean theorem. So I'll just generally state the rule. It says that a squared equals b squared plus c squared, should seem kind of familiar, minus 2 times b times c times the cosine of angle A. We haven't labeled this triangle yet, and it works for any side, and if you know its corresponding angle. But it says, okay, to find a squared, you take the sum of b squared and c squared, and then you subtract this big thing off the end. Let me write down the other two versions just so we have them all. B squared is a squared plus c squared minus 2 times a times c times the cosine of angle B. That's if we needed side B a new angle B. And then c squared is a squared plus b squared minus 2ab times the cosine of angle C. Okay, so there it is. You don't have to memorize it. But if you look at this last version here, c squared is a squared plus b squared minus 2ab times the cosine of C. Let's think about if this were just a right triangle. The cosine of angle C, let's say C were the right angle, the cosine of a right angle is 0. The cosine of a 90-degree angle is 0. So if this were a 90-degree angle, cosine of C would be 0. This entire term would drop off, and look what we would be left with. It's literally just the Pythagorean theorem. So you can think of this as a more complicated version of the Pythagorean theorem, but in reality, the Pythagorean theorem is just a very specific case of the law of cosines, where this whole thing drops out because this is just 0. Okay, so let's fire up this bad boy. Oftentimes we're going to be given the triangle unlabeled, so it's up to us to label it. We can do that any way you want. Let's say this is angle A, this is angle B, and this is angle C. We just have to be consistent, so that means angle A is the one we know, which means this is side A. Since side A is unknown, we have to use this first version. They're all three the same formula. If we labeled the triangle differently, we'd just be using some other formula. But they always say, okay, you add the squares of the other two sides, and then you subtract 2 times the other two sides, right, times the cosine of the corresponding angle of the side that you're trying to find. To me, this thing's even easier to use than the law of sines because it is just kind of a big formula. There's not much algebra involved. Okay, so let's do it. This means that a squared is 30 squared plus 60 squared minus 2 times 30 times 60 times the cosine of the corresponding angle to A, which is 70 degrees. Okay, so it's just a big formula. There's a couple things we have to keep in mind here. I would do this all on your calculator. If I were doing this problem, I would not show any of this work. 30 squared is 900. Sure, anybody can tell me that. 60 squared is 3600. But I don't really care to see that. If you smash this all into your calculator, you're just going to get some big number that's a decimal. And then you're not quite done yet because it's a squared. But I would use your calculator to do this entire step. Just be sure you're careful with things like parentheses if you need them, which you really don't need them. You literally just type 30 squared plus 60 squared minus 2 times 30 times 60 times the cosine of 70. If you want to tell me that 2 times 30 times 60 is whatever it is, 3600, that's great, but you don't need to. So you smash all that into your calculator, you get 3,268, you get about 3268.73. And then the other thing to watch out for is just that you're not done. This is not a formula for A, this is a formula for A squared. So if you got here and you said, okay, that's side A, I would hope that you would then look at this picture and say, this is 30, this is 60, and this is 3,000 something. That can't be right, right? So don't get lazy and think you're done when you're not done. So you're just going to take the square root of both sides of this. But again, you're really not going to write it down. You're just going to do it on your calculator. Just literally type square root ants, and you will get an exact figure. You can really jump right from right here to the answer without showing any work. Just use your calculator. Okay, so when I square root that thing, I don't need to worry about plus or minus, obviously, because this is geometry and it has to be positive. You get about 57.17. Okay, so basically that's the law of cosines. We're not done. We still have two angles to find, right? We don't really have a version of the law of cosines that lets us find angles, although we will very soon. And this is where it gets good because we want to use the law of sines and the law of cosines like in conjunction with each other. So now notice what we have. We have a side and its corresponding angle. So it's not the only way to do it, but it's the way I'm going to do it right now. I'm going to jump back and use the law of sines to finish this problem up. So there's certainly no rule that says you can't use them both in one math problem. In fact, expect that you'll have to. They both work. It's just the way you start off the problem is usually you don't really have a choice of which one to use, because here we couldn't use the law of sines yet. But now we can. So let's see. It's the sine of 70 over side A, which is about 57.17, and now I know that's a rounded figure, and I've said try not to use rounded figures. You could use the ants key in your calculator. We're kind of getting to the point where, well, it's close enough. So we have that ratio, and then it doesn't matter which angle we find first. Let's do angle C. So the sine of 70 over 57.17 has to equal the sine of angle C over 60. And this is actually new for us. We haven't done one exactly like this. We're now using the law of sines to find an angle instead of using the law of sines to find a side. It's not that much harder, it's just different. So you can think about this next step as cross multiplying. To me, it's easier just to think about it as if I multiply this side by 60, I clear the fraction. So I just have to multiply this side by 60. So it's almost literally like you're just moving this 60 over here. So 60 times sine of 70 over 57.17 equals sine of C. Right, so if you did cross multiply this, which is fine to do, you'd get 60 times sine of 70 equals 57.17 times sine of c. You would then divide both sides by 57.17. You would have something that looks an awfully lot like this. So multiplying by the denominator in this case is just a faster way to do the same thing than cross multiplying. It's called just clearing fractions. Okay, so again, all calculator stuff. If you want to be really precise, you do 60 times sine of 70, then you divide it by, you go back up to this step in your calculator and like copy that number with all its decimal places. Either way, what you get is that sine of c is about 0.986. And now you actually have to do an arc sine, right? We have sine of c is this decimal. We don't care. We want to know what angle c is. So angle c is arc sine of 0.968. You're not going to type that into your calculator. You're going to use the ants key, right? You're going to do arc sine of ants because that's going to give you the most accurate thing because it's going to include all the decimal places. So again, it's like you can be tempted to stop here. Don't stop here. You have to find the angle. So that's all in your calculator. Arc sine of 0.968 turns out to be about 80.46 degrees. Which looks pretty good according to our picture, right? That's a pretty big angle. It's not quite a right angle, so 80 degrees might seem kind of right. Okay, so I should have been circling these solutions as I went. We found side A first. We used the loft signs to find one of the angles. You could have totally used it to find this angle instead. The math would have been exactly the same. So we've done everything we needed to do except that angle. Now, could you use the law of sines and just do this same process again to find angle B? Sure, but don't. Why? Because now we have two angles of a triangle, which means we have the third one for basically free. So anytime you have two angles of a triangle, just go ahead and find the third one with the 180 thing, right? Don't do a whole bunch of stuff that you don't have to do. So after this we can get, let's see, we've got A and we've got C, so angle B has to be 180 minus 70 minus 80.46. Which is 29.54. All right, often on a test or something, I'll give you the basic triangle, and then I'll ask you, hey, just label the stuff once you find it. So I don't want to mess up our picture too much. You would just say, okay, you would just label this angle 29.54, you would label this angle 80.46, and you label this side 57.17, and then you would have solved the triangle, which was the whole point.